transformations we're going to be talking about today specifically are translations and reflections. The first thing we're going to do is define what a transformation is. Transformations can also be referred to as mapping, as what we're going to be doing is mapping certain points to new points. Okay? So our definition is in a plane. A mapping is a transformation if each pre-image has exactly one image point. And each image point has exactly one pre-image point. So when we're talking about a pre-image versus an image, your new figure, so whatever you create once you transform it, is called the image, while your original version of those points is going to be called the pre-image. So if you see here in the pictures below, the black is the pre-image, and that is the image that was originally there. The one in red is the new image, so it's just called an image, and it's going to have certain changes made to the original pre-image. So here, the first type of transformation is dilations. This just means that your figure changes size. So if my pre-image was the one in black and my image is the one in red, was this figure enlarged or reduced in size? Enlarged. So that's why it's important to know pre-image versus image, because your if this was your pre-image and this was your image, then it's the other way around, right? The size was being reduced. So it is important to know which one is which. All right, here we have a rotation. All right, and in your rotation, here was our pre-image in black, our image is in red. So it has been rotated in some certain direction. It'll be important to us to state what direction later on. So again, it's going to be important to know which was the original and which one was the new. All right, here we have a translation. A translation just means you take it exactly as it is and move it somewhere else, okay? So you could have just moved it to the left or right. You can move it up or down, or maybe you move it diagonally, but it won't change the way it's facing, right? Like if my piece of paper is up and down, whenever I translate it, it doesn't turn. It just picks itself up and goes somewhere else. Unlike my rotation, where if it moves somewhere else, it's also going to turn as it goes, okay? And then lastly, we have our reflection. And our reflection should be an exact mirror image of one another. So these two calculators are a mirror image of one another when I hold them like this, right? But if I hold them like this, they're not mirror images, right? If I folded it in half there, everything wouldn't match up. So it would have to look like this to be a reflection. All right. So we've got some examples here. It says in these examples, we are going to identify each of the transformations shown as either a reflection, a rotation, or a translation. Okay? And it says in each one of these cases, the image, which one is the image, original or new? New is the one in bold. So the new is the one in bold. All right, I'm going to give you just a moment to look at those images and decide if you think it's showing reflection, rotation, or translation. Okay. All right, guys, what do we think about A? What did A show? So A was slightly turned like this, right? And then it went here. So what happened to get from here to here? What would we call that? Rotation, right? It was rotated about some point. Good. This one is rotation. Okay. All right, B is a little bit tricky. You got to pay close attention to the door and the windows there. What does B show? Rotation as well. It's not reflection, because remember in reflection we said it has to mirror image each other, right? And it's not a mirror image because in the image the door is on this side, in the pre-image the door is on this side. So if I folded it in half it wouldn't match up. So it's not reflection, it is a rotation. Alright. Okay, what about the two smiley faces on C? What do we have there? Reflection, rotation, or translation? Translation, right. It did not turn at all. It was here. We moved it somewhere else. So it is a translation. All right, and then lastly, D shows what? Reflection, rotation, or translation? Reflection, good. You don't just have to have it folded vertically or horizontally. You can kind of fold it along this diagonal-ish line here, right? And everything's going to match up perfectly. So it is reflection. Good. Okay. All right, we have another term that we're going to need to define. This term is isometry. And this means in a plane, an isometry is a transformation that maps every segment to a congruent segment. Okay. In addition to being called isometry, this can also be called a congruence transformation. Okay, so then it gives us 4 more examples. And it says to decide if the transformation shows isometry. Well, isometry would mean that it stays the same what? Same shape and same size, right? That's what congruent means, right? So you're going to look at each one of these pictures and determine if it stays the same shape and same size. If it does, then it shows isometry. And then it says you also need to name the type of transformation that's happening. So remember our types were dilations, rotations, translations, and reflections. So take a look at those images there, decide if it shows isometry or not, and then also tell me what kind of transformation you see. Give you just a minute to do that. Okay, figure A. Did it show isometry? No, because the image got bigger. Okay, so then what kind of a transformation was this then? Dilation. Good. All right, what about B? Did it show isometry? Yes. And what kind of a transformation were these? Or a what? Not a rotation, a reflection, right. If I was to fold right here along this line, everything would match up. So this would be a reflection. Okay, what about C? Does it show isometry? Yes, good. And what kind of a transformation was C? Reflection as well, good. All right, and then what about D? Did it show isometry? No, and it was a dilation. All right. Okay, so flip it on to the next page. All right, so we talked about the different types of transformations. Now we're going to go a little more in depth with our translations. And remember, we said the translation is when you just take it and move it somewhere else, right? You don't change the orientation of the object at all. So, translation, our definition is the result of a movement in one direction. It could also be the end result of two successive reflections. Which is what we call a composite of reflections. All right, our properties of translation. So this is going to be true no matter how we translate it. It will always preserve congruence. Okay, so if I translate something, I'm not going to change the size or shape at all. The second thing that it's going to preserve is orientation. So that means that no matter how I happen to move that figure, no matter what direction, it's not ever going to turn the object. Okay? So it'll stay facing the same way, no matter how I move it. Okay. A translation is a transformation that can be described in a coordinate notation way, because we're going to be changing the place or the spot of each coordinate point. So if you had some original coordinate point, x, y, that can be rewritten whenever you make your transformation as x plus some value. Now that doesn't mean it only can move to the right, okay, because you could be adding a negative number, right? And y plus some value. You guys remember, for transformations of functions, we also use h and k. All right, so anytime I'm moving my x value, I'm moving it left or right. And anytime I'm using k added to my y value, that's going to move things up or down. Okay, so here it says to find the coordinates of the given figure and then find the coordinates of the image after each one of these translations. All right? So they gave us the original image down here, A, B, C, D. So first thing we need to do is write down what the coordinates are for A, B, C, and D. So where is point A? Good. And where is B? 0, 3. And where is C? 1, 1. Good. And where is D? Good. Okay. All right, then number 1 says that they want us making changes to these original points by adding 3 to all of my x values and subtracting 5 from all of my y values. All right, so let's go start with all of the x values. So A was at -3. If I add 3 to that, where is my x value now? 0. All right, for B, if I was at 0, where am I now? 3. Okay, and if for C I was at 1, where am I now? 4. And for D, if I was at -4, I'm now at good. All right, and then for my y values, it says I'm going to subtract 5 from each y value. So if I was at 3, where is that going to put us? -2, good. If I was at 3 for B, then I'm also now at -2. For C, I was at 1. Now I'm at -4. And for D, I was also at 1. So again, -4. So just like whenever we were doing our constructions, guys, remember whenever you make a change to some points, okay, you name the new point that letter prime, right? So this was A. Now I've got A prime. Okay, so I'm going to come over here and graph this on the coordinate plane. So A is now at 0, -2. And B prime is at 3, -2. And C prime is at 4, -4. And D prime is at -1, -4. Okay. All right. Now it says we're going to make changes to our points here with the following. So it says that these points are double prime, right? So that means I'm changing the points from before it. So it says for all of my x values, I'm going to subtract 3, right? Okay, so if I subtract 3 from my x value, where is that going to put us? -3. And did it say to change anything about y? No, so it stays where it is. All right, B, what is my B double prime going to be? 0, -2. And what is my C double prime going to be? 1, -4. And my D double prime? All right, so now I've got these points to come graph. So I got a point at -3, -2 is my A double prime. And then I've got a point at 0, -2 is B double prime. A point at 1, -4 is my C double prime. And -4, -4 is my D double prime. Okay. So these overlap a little bit because we didn't move it far enough away so that they wouldn't. All right. Okay, so then for number 3, I'm going to be leaving x the same, but changing the y value by 4, right? So my x value stays the same at negative, wait, this one says single prime, doesn't it? Okay, so does this one say? Yeah, this one should say triple prime. So add 3, make it 3 lines on each one of those points. That does. We need to have more prime notations. Okay. All right, so for my A triple prime, I'm not changing the x value. What would my new y value be? Always where? Yes, so now I'm going to be at 2. Okay, what's my B triple prime going to be? 2 as well. And then my C triple prime, 0. And my D triple prime. I'm actually going to graph this one on the second coordinate grid so we don't have so much overlap. So I'll put this one here. And they actually may have done this one for us, I think. -3. Yeah, so this one's graphed for us. We just need to make the points. Triple prime here. Okay. All right, and then the last change that we're going to make here is -2 plus 5. Wait a second. That is not the same points. Is this the, oh, this is the original drawing, isn't it? From up above. Okay, all right, sorry. -3, +2 is here. And then 0, 2. And then 1, 0. And -4, 0. Okay. All right, and then the last type of change here, we're actually going to be changing x and y again. So I'm looking at number 3 and making these changes. If I subtract 2 from -3, where does that put me? -5. And if I add 5 to my y value, where does that put us? Good. All right, and then for B, if I was at 0, I'm now at -2. And if I was at 2, I'm now at, good. Okay, for C, I was at 1, now I'm at -1. And I was at 0, now I'm at 5. Good. And then for D, I was at -4, and now I'm at -6. And for the y value, I was at 0, so now I'm at 5. All right, and then we just need to plot these points over here. So I got a point at -5, +7 for my A quadruple prime. And then for B, I'm at -2, 7. And then for C, I'm at -1, 5. And for D, I'm at -6, 5. All right, so you can see we made a whole bunch of different kind of changes here, but it never changed the size of the object, nor the shape of the object, nor did it ever turn it, right? So the orientation stayed the same. Good. All right, flip it on to the next page. We got a little bit more we're going to talk about for transformations. I don't think anybody in here is a junior, so you're probably not in physics yet, right? None of you guys are in physics? No? Okay. All right, so in physics, you'll see what they call vectors, okay? And they describe what a vector is for you here. It's another way to describe a translation. A vector is a quantity that has both direction and magnitude. Magnitude just means size. A vector is represented on a coordinate plane by an arrow drawn from one point to another. And they give you an example here. It says the diagram below shows a vector named FG. Okay? this is read as vector FG. The initial point, or the starting point for this vector, is at F. So we name it just like we would array, right? You start with the endpoint, and then you list some other point on your figure. Your G is going to be the terminal point, or what we would normally in geometry call our ending point, our endpoint. Okay, so as you can see, I went from here to here, but I had to go over and up, right? So your over, your left or right, is what you'll call your horizontal component. Your up or down is what you'll call your vertical component. And the component form for a vector, as you can see, it went right 5 units. So the symbol on either side of the 5 and 3 is like your greater than, less than symbols, is what those are. So it went right 5, so positive 5. And it went up 3, so positive 3. So if you're writing it in vector form, you're going to have these symbols on either side of your numbers rather than x plus something, y plus something. It's implied when it's written in vector form. All right, so right here, it wants us to identify what the vector components are. So if this is vector BC, that means I started at which point? B. All right, to get from B to C, am I going to have to go up or down? Down. So I'm going to go down how many? 2. Okay. So down 2. And will I have to go left or right? Right. How many units? 9. Okay. So just like in a coordinate point, you list your left and right movement first. You guys said we went right 9. So I would say this is positive 9, okay, comma, I went down 2, so should that be positive 2 or negative 2? Negative 2, so I'll put a negative 2 in there. And that would be the vector form of the translation happening here, okay? All right, on B, did I start at T or S according to this picture? S was my start point, okay? For S, did I move left or did I move right? Left, how many? To T. 8. So should I put positive 8 or negative 8? Negative 8. Did I move up or down any? No. So I'm just going to put a 0 in for Y. No change made there. All right. Okay. So now to do a vector component for more than one point at a time. It says you've got this triangle with the points 0, 3. And, 0, 3. 0, 3, 2, 4. And 1, 0. So we've got our A, our B, and our C making up this triangle. And it says we're going to translate it using the vector 5, negative 1. All right, so that would mean my A prime. If I was at 0, where is my x value now for A prime? 5. Good. Okay. And if I was at 3, where's the y value now? 2. All right, for B prime, where would my new point be? 7. Good. Very good. All right, and then lastly, where would our point for C prime be? Nice. So I could come and plot those points on our coordinate plane. I've got a point at 5, 2. So I got A prime here, and then 7, 3. Got B prime here, and C is at 6, negative 1. So there's my C prime. Okay. And remember, our definition of a translation is that it's going to exactly map one point to some new point, right? So all my originals have been moved by the vector 5, negative 1. All right. Okay, and then here at the bottom, all they want us to do is write in either coordinate notation or vector notation the change that's happening. So for A and B, they said to do it in coordinate notation. So remember, our coordinate notation starts with some point, x, y, and we map the changes that are made by adding or subtracting some number to x and y. All right, so it said it moved left 5 units. So I'm going to have x plus or minus? Minus. So x minus 5, right? And what will I have for y if it went down 3 units? Y minus 3. All right, so got to have this whole thing to show coordinate notation, okay? You're showing that you mapped some original point to some new point. Okay, so you guys tried B, and then we're going to share our answer here in just a second. Okay. So for B, what did we have for our coordinate notation? What am I going to have in that second parenthesis there? Good. And then, very good. All right, but then for C and D, it says we're going to write it in vector notation. So remember, for vector notation, we use those less than, greater than symbols, and we don't have to put x plus or y plus some number. We just put the numbers in. So according to C, what should my first number be? -7, right? So we move to the left. And then what would the second number in there be? +4. Good. All right, and then what about for D? What would my first number be? +12. And then the last number would be -10. All right.